Hello everyone, I welcome you all to the Infinity Vision platform. I'm Chandan Sharma and right now I'll be discussing some of the very important formulas as per as your NTSE stage 1 is concerned in physics subject. So if I'll talk about the number of chapter that is there in your class 10th NTSE examination stage 1. So it ranges from current electricity to magnetism and to light and to sources of energy. There is one more chapter that is human eye and the questions also comes from that chapter also at the same time. But the numerical aspect is somewhat less. Okay, also the numerical aspect of your sources of energy chapter is quite less. So our entire focus would be on the three chapters, which is current, electricity and light and magnetism, because most of the numerical comes from these two chapters only. And if I'll talk about the most important chapter of your entire NTSE stage 1 is concerned, it is light as well as current electricity chapter, because most of the questions comes from these two chapters only. Okay, so let us learn about the current electricity chapter, in which the first formula that you must keep in mind is this, the current formula, which is electric current. It is nothing but rate of flow of charge through an area. Okay, the charge if through a given cross-sectional area, suppose you have been given a wire whose cross-sectional area is Q, A, and in T time, Q charge flows through it. So the current within the circuit, the current within the wire is given by relationship charge flown per unit time. Also the total net charge flown is given by I into T. Okay, total charge, where Q is in coulomb and T is in second. So you can easily say that if what is the value of 1 ampere current? 1 ampere current is nothing but if 1 coulomb charge flows for 1 second, then the current is said to be 1 ampere. And again, you can easily find out the charge which is flowing if current as well as time is given to you. Okay, so you must remember these relationship, okay, in order to find out the current and charge and time. Okay, so the next important formula that you must remember is of electromotive force. Okay, what is EMF? EMF is nothing but work done per unit charge. It is equal to the potential difference between the terminal when the terminals are not connected externally. So it is a difference between the potential. And what does it mean? It means that you have been given a cell just like this. If you have been given a cell this is a positive potential and this is at negative potential, it is if no current is drawn from it. So that means if the current is not flowing within the circuit, so that means whatever be the potential difference across it, it is called V, and it is nothing but electromotive force. This is also called as EMF of the cell. You might have heard about EMF of a cell as 1.5 volt, 2 volt and 9 volt battery or 9 volt cell. Okay, that is nothing but EMF of the cells. Okay, and this is also called as work done per unit charge. What is work done? Work done is nothing but if Q charge flows through an entire circuit, then the work done, so the EMF must be equal to work done in moving a Q charge once through an entire circuit. Okay, so that would be, so what would be 1 volt? If I talk about 1 volt, it is equivalent to 1 volt is nothing but if 1 joule charge flows, if 1 coulomb charge flows within the circuit and it takes 1 joule to move that particular charge, then the potential is said to be 1 volt. Okay, so I hope this thing is clear. So you must remember about EMF. EMF is a potential difference across the cell when no current is drawn. When the current is drawn from the circuit, then the terminal potential reduces because of the internal resistance of the cells. Because if a cell is connected to an external circuit just like this. Okay, now if a current is drawn from it, so the potential difference across these two terminals is less than EMF of the cell. You must remember it, because there is certain resistance of the certain internal resistance of the cell which will come into play, and there would be loss in potential which is given by I into small r. Okay, so the value of this potential is given by EMF minus IR. Okay, so this would be the terminal potential now. Okay, because the current is drawn, because of which the cell will come into play, and because of the cell internal chemical reactions, it would have certain internal resistance, and the potential is dropped across it, and there would be loss of this much of potential. Okay, now the potential across the terminal of the cell would be EMF minus IR. Okay, you must remember this concept. Now the next aspect that you must remember is about resistance. Okay, any particular device has certain resistance. Even the wire has got certain resistance. Even different material has got certain resistance. Conductor has very less resistance as compared to your insulators. Okay, as compared to your semiconductors like silicon, germanium, and conductors such as aluminium, which is most conducive, and it is a most important material also, because silver has got most conductivity and it has got very less resistance among all the metals. Okay, so the resistance you can easily find out if you have been given any certain particular wire whose length is L. So you can easily find out the resistance of this wire. If A is the cross section of the wire and L is the length of this wire, so the resistance is given by rho L by A relation. Okay, rho L by A. Okay, which is also given to you, where rho is a specific, rho is nothing but resistivity of a material. Resistance depends upon length and area. Okay, but resistivity only depends upon nature of the material. It does not depend upon length and area. Remember this. You have been given two wire. It is copper wire 1 and this is copper wire 2. Its length is L by 2. Its area of cross section is A. Both have different resistance because its length and length is different. Area is similar, but length are different. So both would have, this would have higher resistance because resistance is directly proportional to length of the conductor. Okay, and inversely proportional to area of the cross section of the wire. Okay, but both would have similar resistivity because both are copper wire only. Okay, so one more thing, the conductivity of the copper wire and silver wire is almost similar, or you can say it silver has got more conductivity, but still because silver is quite expensive, so we may not use it. Silver or gold, we don't use it. Okay, because it is quite expensive. Okay, so you must remember this, and this area of cross section can also be written as, if R is the radius, so area would be pi into R square. Okay, so this relationship you must remember because the direct question may also come at the same time. One more thing that you must remember about the resistance is, if length becomes n times, okay, if keeping volume same, if length becomes n times, suppose its length becomes just like this. Okay, it has been transformed like this. So length becomes n times, then the area becomes A by n times. You must remember this concept also. If length becomes n times, the area becomes A by 10. So obviously, if its length increases, the area would has to decrease. If length becomes twice, the area becomes half, A by 2. Okay, and vice versa is also true. If length becomes half, the area becomes twice. Okay, and likewise you can easily find out the resistance of the wire. Initially the resistance of the wire was this. If length becomes twice, so area becomes A by 2. So the new resistance comes out to be rho L 2L by A by 2, which is nothing but 4 times of rho L by A, which is 4 times of R, 4 times of previous value. Likewise, such type of question do comes in your examination. So remember this thing and this concept. Okay, the next formula that you must remember is that of resistivity. Resistivity is nothing but one of conductivities. This sigma is nothing but a symbol of conductivity. Okay, resistivity has a unit of ohm meter. Okay, so it is inverse of resistivity is inverse of conductivity, that you must remember. This is also one of the terms that you can learn. Okay, the next formula that you must remember is of Ohm's law, very important law. It says whenever if you are applying a potential difference across a resistor, and this potential difference is V, if you are applying a potential difference is V, this potential difference is directly proportional to the current flowing through it. Higher would be the potential difference, higher would be the current flowing through it. Keeping as long as resistance will remain constant, and the resistance can only remain constant only when the temperature remains constant. If temperature is constant, okay, temperature of the wire is constant, then the resistance won't change. You must remember this concept. So this formula V is equal to IR is only applicable when the temperature of the wire will remain constant. Okay, so that means if temperature will remain constant, resistance will be constant. So if this term in this relation is constant, increasing this would also increase this. Don't you think? Increasing this would also increase this. And if we have given our VI graph, so the slope of VI graph, which is nothing but tan theta, so V by I, the slope of VI graph will give you resistance value. Okay, slope of IV graph will give you 1 upon resistance value. Higher would be the graph, higher would be the resistance of that particular material. That you also remember. Okay, the next formula that you should remember is of junction law. It says whatever the current coming into the junction must be total current going out of the junction. Suppose you have been given a junction just like this, and multiple current comes like this, I1, I2. Okay, this is I3 and I4. So I1 plus I2 must be equal to I3 plus I4. Or in other words, it says total current at the junction must be equal to 0. So you can easily write it out also as inward current as positive and outward current as negative. So this must be equal to 0. So this is the junction law that you must remember, or you can easily write it as just like this also. Remember, if I1 is 2 ampere and this is 3 ampere and this is 1 ampere, so this current must be equal to 3 plus 2, which is 5, 5 minus 1. Okay, so it would be 4 ampere. Okay, so whatever current is coming must be the total sum of the current coming must be equal to total sum current going out of the junction. So it would be 3 plus 2, which is 5, and here 4 plus 1, which is also 5. So you must remember this this law at any particular junction of the circuit. Okay, the next thing that you must remember is grouping of the resistors in series combination. In series combination, you have been given a different resistors, suppose R1, R2, R3 and so on. These are R1, R2, R3, R4 and so on. We have been given numerous resistors. The effective resistance of this is called as equivalent resistance, and which is given by relationship R1 plus R2 plus R3 and so on. Okay, if 2 resistors are there, so the resistance would be R1 plus R2. If 3 resistors are there, R1 plus R2 plus R3 and so on up to n resistors. If we have been given n resistors, so till the point it has been n. So the effective resistance across series combination would be this. Also in series combination, if cell is connected to a resistor, the current within the each circuit would be same. Okay, you must remember in series combination the current across each resistor would be same. Also the potential difference across each resistor combination must be equal to the potential difference of battery. So that means I into R1 plus I into R2 plus I into R3 and so on must be equal to V. Okay, so in the series combination, that you must remember this concept. Next is your parallel combination. That what happens in the parallel combination? In parallel combination, you have been given a circuit just like this, where V is the potential, and you have been given number of resistors R1, R2 and so on. You have been given n number of the resistors. So the effective resistance, one resistor that could easily replace all the resistors would be given by relationship 1 upon R equivalent is 1 upon R1 plus 1 upon R2 plus and so on till 1 upon Rn. Okay, for 2 resistors, if only 2 resistors are given, so the equivalent resistance can easily be calculated as 1 upon R1 plus 1 upon R2. Solve it, you can easily get the value of R equivalent as this, R1 plus R1 R2 divided by R1 plus R2. Okay, in parallel combination, the potential difference across each resistor would be V only. Okay, the potential difference is nothing but the potential of cell only. Okay, now you must remember in series combination the current on different branches is also different. Okay, so now the next formula that you must remember as far as current electricity chapter is concerned is just only one formula, that is of power, and that we have already discussed in our work energy chapter. So you must go through the power concept. Power is nothing but work done per unit charge, and also 1 kilowatt hour is nothing but a unit of electrical energy, and that is called 1 unit of electrical energy consumed. Okay, So that those formula that you can also remember at the same time. Now we'll be moving to the magnetism. In magnetism, the only one formula that you must remember and which is very important is force experienced by a charge placed within uniform magnetic field. Or you can say magnetic force on a moving charge. Suppose you have been given a charge Q and it is moving in the magnetic field, constant magnetic field of B Tesla. Okay, so if it is moving in a constant magnetic field of B Tesla and with the speed of V, it will experience force, and which is given by relationship F V cross B, and the magnitude of the force is Q V B sine theta, where theta is the angle between velocity and B vector. It is moving in this particular direction, and here the magnetic field would be in the inward direction. So the angle between them is 90 degree. So that's why sine 90 degree is 1. So the force comes out to be QVB. Okay. If this charge is moving parallel to the magnetic field, then theta would be 0, then force will also be 0. So if it is moving 90 degree, then if the charge velocity is perpendicular, so that means this charge is velocity is perpendicular to the field and the force is perpendicular to both the field and velocity also. Also, this, if it is moving perpendicular to the magnetic field, so the force jet acting on them is always perpendicular to the motion of this charge, and it is always directed towards the center. So that means charge is moving just like this, and the force would always be directed towards the center, whose magnitude is QVB sine theta. Okay, so this force always acts perpendicular to the velocity. Okay, this force doesn't comes into play when this charge moves parallel to the magnetic field. Okay, whenever it is moving in a circular track just like this, because the force is always directed towards the center, so it would experience some centripetal force that we have already discussed. This centripetal force is nothing but mv square by r, where r is the radius of the circular track. So mv square by r must be equal to QVB, where V will gonna cancel out, so R comes out to be mv by QB. Okay, so the radius, radius trajectory that is followed by that particular charge body is given by relationship mv by QB. Okay, this is also very important formula that you must remember, because such type of question do comes whose trajectory is more, alpha particles or electron and different other particles, alpha particles or protons, if both are subjected to the same velocity within the perpendicular magnetic field. So you can use this relationship, and you must remember about alpha particle, what is the mass of alpha particle, what is the mass of proton, what is the mass of different subatomic particles. You must keep in mind of all these things. Okay, now the next formula that you must remember is force is equal to IL cross B. So this is a force experienced by a current carrying conductor placed within magnetic fields. So that means if you have been given a magnetic field just like this, whose magnetic field is B, and I is a current flowing through it. Okay, so this force acting on must be equal to ILB. So whenever a current carrying wire whose length is L is placed within uniform magnetic field, it will experience force, and whose magnitude is given by IL cross B. Okay, so you must remember this concept. Okay, and apart from this, you can also learn about what would be the direction of force acting on it using Fleming's left hand rule. Okay, so using Fleming's left hand rule, you can easily say that if you're placing your thumb and your middle finger and forefinger right angle to each other in such a way that your middle finger is in the direction of current, okay, and this is in the direction of current, and your this forefinger is in the direction of magnetic field, then thumb will give you the direction of force, so it will move in this particular direction. Okay, so this is Fleming's left hand rule that you must remember. Okay, and the magnitude is given by IL cross B. Here this current carrying wire is perpendicular to the magnetic field, so this would be the force acting on it. Okay, now The next topic that you must remember is of solenoid, because so many times such type of questions also comes. What would be the magnetic field inside the solenoid? We know that solenoid is a helical coil structure having current flowing through it, okay, and whose length is very much greater than as compared to its radius, okay, and it would behave like a bar magnet, in which magnetic field would be just like this, okay. So if current is if magnetic field is just like this, so this would behave like a north pole. Here this would behave like a south pole, and inside magnetic field is always parallel, and inside magnetic field is given by relationship mu naught n into I, where n is the number of turn per unit length of the coil and mu naught is a constant, okay, and I is the current flowing through the wire, okay. Higher would be the current, higher would be the magnetic field inside solenoid. And remember, they may ask you what would be the nature of this magnetic field. It is always parallel, it is close to parallel, you must remember. All the magnetic field are inside solenoid is parallel, and its strength is given by mu naught Ni, okay, where mu naught is a constant, which is nothing but magnetic permeability, okay. So these are the things which is there in your magnetism chapter that you must remember, okay. So few questions, you can say direct question may also comes from your other aspect, like motor. So you also go through the motor chapter at the motor concept at the same time, okay. The numerical question doesn't come, only the theoretical portion comes most of the time, so you must remember about all these things. Next we learn about light chapter only. In the light chapter, the most important aspect is the sign convention that you should remember. The sign convention, how to use the sign convention. For sign convention, you must know all these aspects. Like pole is taken as the origin. Suppose you have been given a concave mirror, just like this, and this is its pole. Okay, light is coming from this end. Okay, this would be its focus. This would be center of curvature. It says pole is taken to be origin. This would be the origin. Principal axis as the x-axis. These are the principal axis, so this would be the x-axis. And all the distance are measured from the origin. So whatever the distance you are measuring, it is must be from origin only. Okay, so this would be the, so you will be measuring the distance from pole only. All the distance measured in the direction of incident ray is taken to be negative. That means this is the focal length f of the concave lens or concave mirror. This distance we have measured from pole, and we are moving against the direction of light, because light is coming from this end. This would be the reflecting part of the reflecting part of the mirror, and the light is coming from this end. So this would be, so that means after reflection it will come over here. So you are measuring the distance against the light, so this focal length of the concave mirror is negative, okay. And radius of curvature is also negative. So because you are moving the distance against the light, so it has to be negative. And all the distance measured in the direction of motion of the light is taken to be positive. Suppose image is formed over here, so this would be, V would be the in this particular direction only, so this V comes out to be positive only, okay. Rest, if you are moving against the light, all the distance is taken to be negative. Same is a case which is applicable for the sign convention is also applicable for lenses only. Lens like convex lens as well as concave lens. Okay, all the distance measured in the direction of light is taken to be positive. All the distance measured against the in the direction against the propagation of light is taken to be negative. That you must remember. Okay. Sign convention is very, very important as far as your light chapter is concerned. Now, what you can learn about is spherical mirror formula. Spherical mirror formula, like 1 upon f, focal length is given by relationship, and is nothing but 1 upon v plus 1 upon u. So what is u over here? U, suppose you have been given a concave lens, and this is object, and you will get an image over here of an object. So this distance is u, and this distance is v. So u is your object distance and v is your image distance. Okay, f is your focal length. Okay, suppose here f you are getting. Okay, so this would be the focal length. So this focal length is also given by twice of, suppose this is center of curvature, so this distance would be radius of curvature. So this focal length is twice of radius of curvature, that you must remember using this relationship, and you can also use the spherical mirror formula. Here also lateral magnification or magnification can also be written as height of image divided by height of object. So this would be height of image divided by height of object, which is h1, which is also given by relationship minus v by u. These two important formulas you must remember as per as your spherical mirror numerical is concerned. Okay, using these two different formulas with proper sign convention, you can easily do the numerical. Okay, here h2 is negative because it is below the principal axis. Okay, so so two more concepts that you must remember in the sign convention is all the distance measured below the principal axis is taken to be negative, all the distance measured above the principal axis is taken to be positive. So h1 is positive and h2 is negative. Okay, and v and u can easily be accordingly negative or positive. For concave mirror, focal length is negative. For convex mirror, the focal length is positive. Okay. Next thing that you must remember is of refraction part. What is refraction? As of now, we were talking about reflection part only. What is refraction? Refraction is nothing but bending of light while light moves from one transparent medium into another. Okay, so if a light moves from one transparent medium, suppose air and water is there, and light comes just like this, and it bends just like this. Okay, so this is incident ray, and this is refracted ray, not reflected ray. So this angle small r is nothing but refracted angle, and this is incident angle. Okay, you must remember this concept. And suppose air having refractive index of n1, air having refractive index of 1 only, so let it be n1, and water let it be having refractive index, let it be n2. So this relation is nothing but your Snell's law relation slip. Okay, Snell's law says that sine of the angle of incidence to the sine of angle of refraction is constant. So because ratio of the refractive index must be constant. Okay, so sine of angle of incidence to the angle of refraction must be constant. So this is nothing but refractive index of second with respect to first medium. So this can also be written as, how can you write it just like this? You can write it as n21. Refractive index of second medium with respect to first is nothing but sine of angle of incidence to the sine of angle of refractions. Okay, and this is also given by relationship velocity of light in first medium divided by velocity of light in second medium. So you must remember all this concept in order to do the numerical aspect as per as refraction is concerned. Okay, so now we'll be moving to the critical angle concept first, because such type of question also comes in your examination. The critical angle concept only is applicable only when the light is moving from optically denser to the optically rarer medium. So what is this concept? It says you can easily find out the critical angle concept, the critical angle between the two interface using the relationship. We know that if light moves from denser medium, let this denser medium having refractive index of n, and it is moving to the air. Okay, and this is at a certain incident angle, so it will just go like this. Okay, so this would be the refracted angle. Obviously, if light is moving from denser towards rarer medium, it will move away from the normal. If it is moving from rarer towards denser medium, it will move towards the normal. Okay. So at any angle of incidence, at any particular angle of incidence, if this refracted angles becomes parallel, this refracted ray becomes parallel to the interface, then this angle of incidence is called as critical angle between these two surfaces. So that means the situation is, if this angle becomes equal to this incident angle becomes equal to critical angle, at this particular point, this refracted ray becomes parallel to the interface, and this angle becomes 90 degree. Okay, so that means you can easily use the Snell's law relationship as sine of, so you can easily use the relationship as sine of 90 degree divided by sine of angle of incidence, which is critical angle, must be equal to refractive index of second medium, which is air, with respect to first medium, which is this medium. Okay, I have used the Snell's law, and what you can do is sin 90 degree is 1, sin 90 degree is 1, so this critical angle concept that comes out to be is, okay, it will go over there. So here we have calculated as this is second medium and this is first medium. Okay, so okay, it would be sine of, this would nothing but it would be n by 1, not 1 by n. So this would be n by 1, not n by, so not n by 1. So here what you can see is critical, this is nothing but refractive index of second medium with respect to first medium is nothing but, so refractive index of second medium with respect to first medium. So it would be this, and sin theta is sin 90 degrees 1. So this critical angle that comes out to be this theta c must be equal to 1 upon n that we are getting over here. So that means from this relationship you can easily find out the value of critical angle between the any two interface. And here the second interface is air, so that's why its refractive index is 1. Okay, so that means some of the critical angle between the different interfaces you must remember, like water and air interface, like glass and air interface. What are their critical angles that you must remember? If light falls on a interface and whose critical angle is, and this incident angle is greater than critical angle. So this angle is now, incident angle is greater than critical angle between these two interfaces. So total internal reflection will gonna take place. This is called total internal reflection. ये हो जाएगा भाई. Okay. So that means the condition is if this incident angle is greater than critical angle, then total internal reflection takes place. And total internal reflection only takes place when light moves from denser towards optically rarer medium. Okay. So that means these are the concepts that you must remember, and there are few more concepts that you must remember is the power of a lens. Okay. Apart from this, you must remember about lens formula, like 1 upon f focal length is equal to 1 upon v minus 1 upon u, and the magnification is image height by object height must be equal to plus v by u. You can also remember this formula also. This is for lens. Okay, where v is the image distance from the optical center and u is the object distance from the optical center, and image height and object height and v and u. Okay, for lens you can use this relationship. Also you can learn about this power of a lens as formula as power of a lens can be easily calculated as if suppose you have been given a lens, this is convex lens whose focal length is f, so its power is given by relation 1 upon f. Okay, for the combination of lenses the power are p1, p2 and p3. What does it mean? You have been given numerous, suppose this lens is having power of p1, so focal length is f1. Again one more lens is there in the combination, its power is p2 and focal length is f2. Okay, so these are the combination of convex and concave lens. So that means its power, the effective power or the combined power is given by relationship combined power is p1 plus p2, and if you have n number of the lenses are there, so the combined power would be p1 plus p2 plus p3 and so on. Okay, and the individual, this power, this p1 must be equal to 1 upon focal length of first. Okay, and this p2 is also given by 1 upon f2, don't you think? So it can easily be written as 1 upon f1 plus 1 upon f2 and so on. So there is one lens which can replace all these lens combination of the lens whose power must be equal to p1 plus p2 and so on. Okay, and whose focal length is given by relationship capital P is 1 upon capital F. So from that relation, if power is known, you can easily find out the focal length of the combined power of that particular lens. Okay, so these are the things which is all about your light chapter, and the only last aspect that you must remember is about prism. Okay, if a light passes from air to prism, obviously dispersion also takes place. That phenomena, that is splitting of light into 7 different constituent color, is also called dispersion. Okay, so you must also remember about all those things. But right now I'll be discussing some of the formulas which is related to your monochromatic light only. So monochromatic means light has been of single wavelength. Just light comes just like this. This is a normal to the interface. So it will bend just like this. And again, this will bend like this. Over here, it will go just like this. This is incident ray, and this is emergent ray. And this angle is angle of emergence. This angle is angle of incidence. Okay, this is angle of a prism. So light has to travel just like this, but it will gonna refract it, and again it will gonna refract it just like this. So this angle, the angle between path of the incident ray and the emergent ray is called as angle of deviation. And this angle of deviation is given by relationship I plus E minus A, where A is the angle of a prism, I is the incident angle, and E is the emergent angle. And at certain angle of incidence, when angle of incidence becomes equal to emergent angle, you'll get a minimum value of this deviation. Okay, you'll be getting minimum value of the deviation angle. It is only possible when incident ray and emergent ray becomes equal. At this particular thing, if angle of incidence becomes equal to angle of emergence, so this becomes parallel to the base of the prism. Okay, so this refracted ray becomes parallel to the base of the prism. Okay, also when this angle is very small, if A is very small, then this minimum deviation is given by relationship n minus 1 into A, where n is the refractive index of this glass. Okay, so you must remember all these formulas in order to do the numerical aspect of your physics is concerned as far as class 10th is concerned. Okay, I hope everything is clear to you. All the formulas, the important formulas which is related to your class 10th and standard as far as NTSE stage 1 is concerned. You just go through all the previous year questions at the same time, because the time is limited, so you must go through the questions. And at the same time, what you can do is you can join our institution's mock test, NTSE mock test, okay, so that you can make out at what level you are. Okay, and rest whatever the things which have been taught to you, you can remember all these things. Okay, so with this I'll end up this session. Best of luck for your NTSE stage 1 examination. Thank you.